Force is one of the important physical quantity as many other quantities depend on it, and this was being found out by the Sir Isaac Newton. So he saw when an object is falling from a tree, that's the apple falling on a tree, and it strikes in his mind that why that apple is coming down. So after that, a law of gravitation was being discovered. So law of gravitation means the force of gravity, that a larger object is attracting a smaller object, right? So hello students, welcome to my next online class. So I am here with a new chapter, that is force. So what is force and what are the different effects of force? So this we are going to learn in this particular video, right? So watch the video till the end. So without any wasting our time, so let's start our topic today. So what is force? Force is an external agency which can be in a form of push or pull. So whenever you are pushing any object, and if the direction of motion of that object is increasing from you, that means if the distance is increasing from you, that means the object is being pushed. But whenever you are pulling an object, if the direction of motion is towards the source, then we say that the object is being pulled. So not only push and pull, so there are different effects of forces. So different effects of forces, you see, force can produce or tend to produce motion, right? So if an object is at rest, so it can make an object move, but you see, it is not necessary that when you are applying a force on an object, that object will definitely move. So like this, when I am pushing a wall, so I am applying force here, but the displacement of this wall is 0. So I am trying to push, right? So when I am trying, the motion means I am trying to push this wall, the motion is ceased here. But when I am pushing a table or any book, it will move away from me, that means pushing. And when I am pulling it, that means the distance, the direction of motion is towards the source. So here it can produce or it can tend to produce motion. Next, it destroys or tries to destroy the motion in a body, increases or decreases the speed of the body. So we can increase the speed also, we can decrease the speed also. Like for example, when we try to push any object which is at rest, so it gains momentum and it starts moving. Similarly, when an object where initially it is at motion, when it comes towards us like a rolling ball, then if we apply force here, then we can be able to stop that ball, right? So increase or decrease the speed of the body, changes in direction of the motion. So a cricketer, when he hits a 6, that means he is changing the direction of the ball, right? A bowler is throwing towards a batsman, and the batsman with the help of bat is just changing the direction of the ball, so by applying a force. So therefore we can change the direction of the motion by applying a force, can change the size or shape of the body. So on application of force, we can change the dimension, that is configuration of the system. Like for example, a spring, when you stretch a spring, then it will become lengthy. When you squeeze a duster, then it will become small, that means it will change the shape, right? So these are the different effects, you can say, effects of force. So these effects has been included in the definition itself. So in the definition also you can include this one, right? So in the previously it was believed that when one object is not in contact with the other object, they cannot apply force, or a force is applied one body to another body only when it is contact. No, this is not correct, right? So force can be applied on one body to another without any physical contact, that means contact force or non-contact force. So contact forces are those forces where the two bodies are in contact, and non-contact forces are those forces where the two bodies are not in physical contact. Like if I place a north pole of a magnet and south pole of a magnet, they will attract each other. Similarly, if I place north and north facing each other, then they will repel each other. Therefore one magnet is applying a force on another, but they are not in actual contact, so this is called non-contact force. Similarly, gravitational force, magnetic force, electrostatic force, these all are non-contact force. But whereas this tension, or you see this friction, right, these are called contact forces, right? So these are the different effects of forces. So according to Newton's second law of motion, F is equals to ma. That means force is the product of mass and acceleration, right? So what will be its SI unit? So SI unit of force is 1 Newton and mass is 1 kg, that is we can write kg also, and here meter per second square, right? So we can say that when it is 1 Newton, when a force is 1 Newton, a force is 1 Newton when a body of 1 kg is moved by an acceleration of 1 meter per second square. So when you are applying a force on an object, and if the weight of that object is 1 kg or mass is 1 kg here, and it is moving with an acceleration of 1 meter per second square, then we say that 1 Newton force is being applied, right? So what will be its CGS unit then? CGS unit of force is dyne, right? SI unit of force equals to Newton, and it is denoted by capital N, right? Now 1 Newton equals to kg meter per second square. Now if we want to find the relation between this CGS unit and SI unit, so we can easily derive from here. Like you see, just now we have seen F equals to MA, F equals to 1 Newton if it is 1 Newton, and M equals to 1 kg into 1 meter per second square, right? So 1 kg can be written as 1000 gram, because we are converting now to CGS unit, into 1 meter. 1 meter can be written as 100 centimeter per second square. So 3 plus 2, that is 10 to the power 5 gram per centimeter square. 10 to the power 5 gram per centimeter square is dyne. Okay, so 1 Newton equals to 10 to the power 5 dyne. So this is the relation between CGS unit and SI unit. So you have to write for this definition of force, what are the different effects of force, right, in your exercise book, and also the notes which I will be teaching today, like rotational and translational motion. Whenever we are applying a force on an object gains some momentum and it tries to cover some distance, or we can say it acquires some motion. So when a force is being applied on an object, the object can move in translational, like a translational motion, or it can has a rotational motion. So when a force is being applied on an object and object is moving in a straight line, we say it to be as translational motion. It is possessing translation, right? Like for example, a ball is pushed by a player with a hockey stick, or a car is moving in a straight line. But when a force is being applied on an object is moving and it is fixed, means it is pivoted to a fixed axis. So that type of motion is called, said to be as rotational motion. So when a force is being applied on a body, rotates the body about a certain axis, then the motion is said to be as rotational motion. Like for example, in a windmill, the blades of the windmill get rotated by the force exerted by the wind, right? So this was translational motion and rotational motion. So not only here translational, rotational, in our day-to-day life also we experience the turning force, like while opening the tap, while opening the cap of any bottle, right? So these are called the turning forces, right? So this one will go much more detailedly in my next online class. So for this video only this much. See you soon in my next video.